Ever get the feeling that in AI, bigger is always better?
Like just pack in more parameters and you'll get a smarter model.
Yeah, exactly. Like a bigger brain means, well, more intelligence.
It's kind of intuitive, right?
But what if I told you that sometimes a smaller AI can actually be better at a very specific task?
Ooh, now you've got my attention. Tell me more.
Well, get this, a 27 billion parameter model, which isn't small by any means, but
But tiny compared to some of the behemoths out there.
exactly, can sometimes outperform models hundreds of times its size.
Wow, that's really counterintuitive. Where's this all going?
This is the kind of unexpected twist we're going to be unpacking today. You ready to dive in?
Absolutely. Count me in. I think our listeners are in for a real treat today.
We're going deep into the world of AI, evaluating AI.
It's a mind-bending concept when you really think about it. Almost like the robots are marking their own homework.
It's wild, right?
Totally.
So, in this deep dive, we're focusing on a really innovative approach called self-principled critique tuning. It's often shortened to SPCT,
Catchy, right?
and we'll also be exploring the DeepSeek-GRM family of models that have been built using this really groundbreaking technique.
Now, all of this is based on a recent research paper that's really pushing the boundaries in AI evaluation. And one thing that makes this work especially interesting, I think, is that the researchers didn't just build new models.
They actually came up with some totally new ways of training those models
Exactly. So it's not just about performance, it's also about, the process of how we get there.
and how to make those evaluations more reliable and how to scale them up. So, our mission today, you could say, is to unpack the core innovations and insights from this paper.
We really want to understand how these DeepSeek GRM models, trained with SPCT, represent a pretty big step forward on how we evaluate AI and maybe even how we think about AI development as a whole.
And a step towards, I'd say, more academically sophisticated and nuanced AI evaluation.
Definitely. More nuanced, for sure.
Okay, so I think before we get into all the technical details, let's start with the basics. Why is it so important to have good systems for evaluating these large language models in the first place?
Well, I mean, accurate evaluation is essential if we want these models to keep getting better,
Oh,
right?
sure.
And not just better at specific tasks, but also better in the sense that they are, aligned with what we want them to do. Helpful, accurate, safe, all of that.
Right, like we don't just want AI that's good at, say, generating text, but AI that generates text that is also, truthful, unbiased, not harmful, all those things.
Absolutely. And the thing is, traditional evaluation methods often rely on these very specific scenarios that we design.
Right, like a set of math problems or something.
Yeah, exactly. And they have these very rigid rules for what counts as a good or bad response. It's very black and white.
So those systems work in those very narrow situations, but when you move outside of those control environments, like into the real world where things are much more messy and complex, those rule-based systems kind of fall apart.
They really do. The real world just has too many shades of gray for a simple rule book to cover everything.
And this is where the whole idea of reward modeling becomes so important. How do you give an AI feedback, like a reward signal, that tells it, hey, that was a good response, or nope, not quite there yet?
And how do you do that in a way that can handle all the nuance and complexity of the real world? It's a huge challenge.
And that's exactly where these generative reward models, or GRMs, are starting to make such a big difference.
So with GRMs, we're moving beyond just assigning a simple numerical score to a response, right?
Right. It's not just like a 7 out of 10 kind of thing.
Exactly. These models can provide much richer feedback, and in this case, they can even generate these detailed critiques that explain why a response is good or bad.
It's like they're writing little essays, like a teacher grading a paper.
That's a great analogy. And from an academic perspective, this is really exciting because it allows us to get a much deeper understanding of how these models are thinking and why they make the decisions they do.
So it's not just a black box anymore. You're actually getting insight into the AI's reasoning process.
And maybe even more revolutionary is that some of these GRMs, like the ones we're focusing on today, can even come up with their own evaluation criteria, their own fundamental principles.
So they're not just applying rules that we've given them, they're actually creating their own rules.
Exact.
Wow. So instead of saying, okay, this response gets a 6 out of 10, they're saying, well, based on my own internally generated principles, which I've developed, this response demonstrates a good understanding of the core concepts, but it lacks specific evidence to support its claims.
Precisely. And that's a really profound shift because now instead of just getting a score, You're getting a detailed explanation that helps you understand exactly where the model needs to improve.
That's a huge step forward in terms of, making AI evaluation more transparent and understandable. And you mentioned earlier that this ability to generate their own principles is a core part of what makes this self-principled critique tuning, or SPCT, so unique.
Absolutely. It's right there in the name, self-principled. The idea is to empower these GRMs to not just apply rules, but to actually generate the rules themselves.
Okay, so help me wrap my head around this. How does SPCT actually enable a model to become, self-principled? What are the steps involved?
So SPCT is a two-stage process. The first stage is called rejective fine-tuning.
Rejective, like it's rejecting something.
Yep, exactly. So during this stage, the model is learning to generate these evaluation principles and the critiques that go along with them in the correct format.
And the rejecting part comes in because,
Well, the model makes a prediction, right, based on the principles and critique it generated. And if that prediction doesn't match the correct answer, then that whole attempt gets tossed out, rejected.
so it's a learning process where the model learns by making mistakes and then discarding those mistakes.
Exactly.
And it's not just about getting things wrong either. If the model gets something right consistently, like it's just too easy for it, that input gets rejected too.
Yeah, because that's not helping the model learn anything new.
It's like a teacher giving a student a test. And if the student aces it without even trying, the teacher might think, okay, this test is too easy. Let's move on to something more challenging.
Exactly. So this rejective fine-tuning process ensures that the model focuses on the examples that are actually going to help it learn and improve.
So once the model has gone through this initial training stage, what happens next?
So then we move on to phase two, which is rule-based online reinforcement learning.
That's a mouthful.
I know, right? But it's actually not as complicated as it sounds. Basically, in this phase, we're refining the model's ability to generate those effective principles and critiques.
And we're doing that how?
Well, we're using accuracy rules to give the model feedback on how well its generated principles and critiques are leading to correct reward predictions. But here's the really interesting part.
Okay, tell me.
We're not explicitly rewarding the model for following a specific format for its principles and critiques.
So how do we make sure it doesn't just start, spitting out gibberish?
We use something called a KL penalty.
KL, like the divergence.
Exactly. It's a way to encourage the model to keep its outputs consistent. We don't want it to suddenly start writing its principles in a completely different style than it did before.
So it's like we're saying, hey, be creative and come up with your own principles, but keep it consistent and understandable.
Exactly.
And how does this ability to generate its own principles make the whole evaluation process more scalable, especially when we're using the model in a real-world setting?
Well, because the model can tailor its evaluations to the specific input and response it's seeing, it doesn't have to rely on this fixed set of rules that might not always be applicable.
So it's more flexible and adaptable.
Exactly. And that becomes super important when we start talking about inference time.
Inference time, meaning when we're actually using the model to evaluate something.
Right. So instead of applying the same rigid criteria to everything, the model can adjust its assessment based on the context. And it can do that even when we're using something called sampling.
Sampling, like taking a sample of something.
Yeah, kind of. In this context, it means that instead of just generating one set of principles and a critique for each input, the model generates multiple sets.
So it's like we're getting multiple opinions from the same expert.
Exactly. And then we can combine those opinions to get a more robust and accurate overall evaluation.
And DeepSeek-GRM is one of the models that uses this sampling technique, right?
Right. And DeepSeek-GRM takes things a step further by using something called a meta-RM, which stands for meta-reward model.
Meta, like it's above or beyond the regular reward model.
Exactly. It's like a reward model for the reward model.
So it's like a supervisor checking the work of the main evaluator.
It's a great way to think about it. So when DeepSeek-GRM generates those multiple sets of evaluations through sampling, the meta-RM steps in and assesses the quality of the underlying principles and critiques.
So it's not just taking an average of all the scores.
No, it's actually a weighted average. The scores that came from higher quality principles and critiques, as judged by the meta-RM, get more weight.
Oh, so it's not just about how many evaluations you get, it's about the quality of those evaluations. That makes a lot of sense.
And the really cool thing is that this approach can actually lead to performance that's comparable to or even better than much larger models trained in the traditional way.
So you don't necessarily need to keep building bigger and bigger models to get better results.
Exactly. Sometimes being smart about how you use a smaller model can be just as effective.
I like the sound of that. More efficient and just as good, if not better.
And the research paper actually backs this up. They did a ton of experiments and found that DeepSeek-GRM consistently outperformed a bunch of other models, including some really big ones, on a variety of different benchmarks.
So they didn't just test it in one specific scenario, they really put it through its paces.
Yeah, they tested it on things like reward bench, PPE, RMB, and real mistake. These are all well-established benchmarks that evaluate different aspects of how well a model can evaluate other models.
Sounds pretty comprehensive. And what about the specific role of those self-generated principles? Did they actually make a difference?
Oh, absolutely. They did some ablation studies, which basically means they removed certain parts of the model to see how it would affect performance. And when they took away the principal generation capability, DeepSeek-GRM's performance took a nosedive.
So it wasn't just a gimmick, it was actually a crucial part of what made the model so effective. You mentioned earlier that this pointwise GRM approach is really flexible in terms of the input it can handle. Can you elaborate on that a bit?
Sure. So the architecture of DeepSeek GRM allows it to evaluate a single response in isolation, or compare two responses, or even evaluate multiple responses at the same time.
So it's not limited to just one specific type of evaluation task.
Exactly. And that's a big advantage over some older reward modeling techniques that were specifically designed for pairwise comparison, meaning they could only compare two things at a time.
And it sounds like these innovations might have implications beyond just DeepSeek GRM itself.
Oh, definitely. They found that the principles generated by DeepSeek GRM could actually be used to guide the evaluations of other language models.
So it's like one AI is teaching another AI how to be a better judge.
That's a really interesting way to think about it. And in some cases, using these transferred principles actually led to better performance than using manually created principles.
Wow. So it's not just that these models can learn to evaluate themselves, they can actually learn to evaluate other models too.
It's pretty amazing. And it raises all sorts of questions about how we might be able to use these techniques to improve AI systems more broadly.
So we've got these AI models that can generate their own evaluation principles, transfer those principles to other models, and even use a meta reward model to ensure that those principles are high quality. What else did the researchers find?
They also looked into how well DeepSeek GRM could generalize to new topics and situations.
Meaning, could it handle things it hadn't specifically seen during its training?
Exactly. And they found that it actually did a pretty good job, even when given tasks that were outside of its training domain.
So it's not just a one-trick pony, it can actually adapt and learn new things.
Yeah, which is really important if we want to build AI systems that can truly function in the real world.
I was also intrigued by that finding about how the model's reasoning process seemed to adapt based on the complexity of the task.
Oh yeah, they found that DeepSeek GRM would actually adjust the length of its critique, which is kind of like a measure of how much it was thinking about the problem based on how difficult the evaluation was.
So for simple tasks, it would keep things short and sweet, but for more complex tasks, it would go into more detail.
Exactly. It's like it was learning to be more efficient with its reasoning resources.
Fascinating. So taking a step back and looking at the bigger picture here, what are the main takeaways from this research? What's the significance of all of this for the field of AI?
Well, I think one of the biggest takeaways is that we might not always need to rely on massive resource-intensive models to get good results.
Sometimes, a smaller model with the right training and techniques can be just as effective, if not more so.
Exactly. And this research really highlights the importance of thinking creatively about how we train and evaluate AI systems.
It's not just about throwing more data and computing power at the problem, it's about coming up with smart new approaches.
And in this case, that smart new approach is all about enabling AI to be more self-reflective and to develop its own internal standards for what constitutes good or bad AI.
So, what does all of this mean for the future? What are the potential next steps in this line of research?
Well, there are tons of exciting possibilities. The researchers themselves mentioned several in their paper. One idea is to start incorporating external tools into these GRMs.
Tools like what?
Things like code interpreters or search engines. The idea is that these tools could help the models generate even more accurate and insightful critiques.
So, if a model is evaluating a response that requires some specialized knowledge or a specific calculation, it could actually use a tool to double check its work or gather more information.
Exactly, and that could lead to some really big improvements in evaluation accuracy.
What else is on the horizon?
Well, another interesting direction is to break down the process of generating principles and critiques into separate stages. That way, we could have more control over each step and potentially improve the overall quality of the evaluations.
And that could also make it easier to understand how these models are actually working, which is always a good thing.
Absolutely. And there's also the possibility of using these techniques for offline evaluation.
Meaning evaluating models that have already been trained.
Right, so instead of just evaluating models during the training process, we could use these GRMs to get a deeper understanding of how well a model performs on a variety of different tasks after it's already been developed.
And that could be really valuable for, making sure that AI systems are actually meeting the standards we set for them, even after they've been deployed in the real world.
Exactly. It's all about ensuring that AI is not just powerful, but also trustworthy and reliable.
So this research really opens up a whole new world of possibilities for how we evaluate and improve AI systems.
It does, and it really makes you think about the future of AI and the role that AI itself will play in shaping its own development.
I mean, it's mind-blowing to think that we're now at a point where AI can not only generate its own evaluation criteria, but also transfer those criteria to other AI systems.
It's a really exciting time to be in this field, and it raises a lot of really interesting questions about where all of this is going.
Like, will we eventually reach a point where AI can evaluate itself so well that human oversight is no longer necessary?
Or will there always be a need for human judgment and expertise in guiding AI development?
It's hard to say for sure, but what we do know is that this research is pushing the boundaries of what's possible in AI evaluation, and it's opening up a whole new frontier of exploration.
And that's what makes it so fascinating.
Absolutely. So, to sum it all up for our listeners, what are the key takeaways from our deep dive into SPCT and DeepSeek-GRM?
I think the biggest innovation is the SPCT framework itself. The idea that AI can generate its own evaluation criteria is incredibly powerful. And DeepSeek-GRM shows that this approach can lead to real, tangible improvements in performance.
It's a paradigm shift in how we think about AI evaluation.
It really is. And it has the potential to change the way we develop and deploy AI systems in the future.
So, if you're interested in learning more about this groundbreaking research, we highly recommend checking out the original paper.
And there are tons of great resources online if you want to delve deeper into this topic.
Thanks for joining us for this deep dive. We'll be back next week with another fascinating look at the latest advancements in AI.
Chris, see you then.
Bye.